Try a quick thought experiment. Picture the physical space directly behind you right now. Does that room actually exist while you aren't looking at it? Or does it physically assemble itself at the exact millisecond you turn your head to check? Rizwan Virk has spent his career examining that exact question. He is an MIT-trained computer scientist and a successful Silicon Valley developer who helped back major platforms like Discord. Based on decades of coding and observing the evolution of virtual worlds, Virk has arrived at a specific conclusion. What we experience as a tangible physical reality is actually an information-based simulation, functioning with the same logic as a video game. The immediate objection from traditional physicists is usually about scale. They argue that rendering the entire physical universe down to the quantum level would require a computer larger than the universe itself. The math for tracking every subatomic particle simultaneously suggests a staggering resource cost. That objection relies on an assumption about how rendering actually works. It assumes the universe processes everything, everywhere, all at the same time. Computer scientists know that highly advanced simulations do not operate that way. In the early days of video game design, hardware was severely limited. Programmers had to manually store and track every single pixel on the screen. Modern game engines solve memory limits using procedural generation. Instead of rendering continuously, the engine only builds the environment within the player's active field of view. Everything outside is held as mathematical probabilities. Detail materializes only when the player gets close enough to observe it. To build a simulation the size of the cosmos without requiring infinite processing power, an architect would be forced to use that exact same optimization. They would have to rely on an only render when observed set of rules. This brings us to the quantum observer effect. In quantum mechanics, subatomic particles exist in a state called superposition. They are a blur of mathematical possibilities, occupying multiple potential states at once, until a measurement or observation forces them to snap into a single physical reality. The parallel is exact. Quantum superposition behaves perfectly like unrendered video game data, sitting in the background as raw code, waiting for a player's camera to look its way. In physics, the Planck length is the smallest measurable distance. Space is made of discrete blocks, functioning like digital pixels. The same applies to time. Planck time demonstrates that time ticks forward in discrete increments, acting as a universal frame rate. Through the lens of computer science, the bizarre paradoxes of quantum indeterminacy serve a practical function. They operate as a highly efficient memory optimization technique that is built directly into the fabric of the universe. In 1977, science fiction author Philip K. Dick suggested that we live in a programmed reality where variables are occasionally altered, resulting in the sensation of déjà vu, the feeling of witnessing a timeline being rerun and revised. Today, we can track these potential alterations. The Mandela Effect is a mass phenomenon where large, unconnected groups of people remember a version of history that contradicts the current physical record. These discrepancies often center on specific physical details. Countless people vividly remember Auguste Rodin's The Thinker resting its forehead on a clenched fist, even though the physical statue rests its chin on the back of an open hand. This brings us to John Wheeler's delayed choice experiment. In quantum physics, this experiment demonstrates that a measurement made in the present can actually reach backward in time to dictate the specific physical path a photon took in the past. Applying this logic to the simulation hypothesis, Virk proposes that our history is not a fixed linear record. Like an offline world in a video game, the past exists as a set of probabilities that are generated on demand the moment they are observed in the present. Under this framework, mass misremembering is a feature of the system, not a bug. These shared false memories operate as the artifacts of an editable timeline, the digital scars left behind when alternate histories are patched and merged. Virk's exploration goes beyond code. His research into out-of-body experiences and ancient esoteric traditions revealed an alignment with quantum physics. Both disciplines arrive at the conclusion that the physical body is merely an interface. This redefines human consciousness. We are not the code itself. We are the external player, logging into a biological avatar to experience the rendered world. The ultimate hurdle for this theory is our perspective. Because our consciousness is operating from inside the system, we have no physical mechanism to observe the hardware running our universe. It remains an untestable hypothesis, despite being mathematically sound. If we truly exist inside a highly optimized, dynamically rendered virtual construct, the technical structure of space and time begins to make sense. But it leaves an even deeper mystery. Why was the system turned on? And who exactly is playing the game?